Iming, co-founder and chairman of Transformer Robotics. Professor Chen received his BS from the National Taiwan University and his MS and PhD from California Institute of Technology. He is a tenured full professor at the School of Mechanical and Aerospace Engineering of Nanyang Technical University. He was director of Robotics Research Center and Intelligent Systems Center in NTU, and now technical advisor for National Robotics Research Program Office in Singapore. His interests are in logistics and construction robots, human-robot interaction, and industrial automation. To talk about co-innovation of robotics, AI, and construction technologies in Singapore, please welcome Professor Chen Iming.
Thank you, Ela. Can you hear me, right?
Yeah. Yes, we can hear you.
Okay, great. It's a great pleasure to be attending this webinar to share our works in Singapore. So we had a roundtable meeting 2 days ago, so that we just briefly talk what we're doing. So that today I'll give you some more details that what we're doing. So look at how would robot be able to work with human here now for the construction sectors. Yeah. So let me start my screens. See if you can see that. Okay. All right. So can you see my screen, right? Yeah. Okay, so let me pull out. Okay, actually, I changed my title a little bit because construction robot is a more or less is new field if you look at compared to industry robots. That we not only need industry players to come in, but we may also need the government, all this to really come in to look at it. Yeah. The construction productivity, I think, as Oliver just mentioned, I think it's low compared to the total economy globally, and of course much lower than manufacturing. And in terms of digitization, this is also low compared to many sectors. And this digitization is also one of the index for the productivity. But we know that construction is a very complex ecosystem, right? We know in manufacturing is also, but in the construction industry that actually involve from the very beginning to the architecture, developer, contractors, and even after building completed, you have the facility management as well. So now, because of the advancement of robotics, IT, information technology, AI, all these actually now we are trying to move up the construction sectors with the digitization effort. So now, how do we really do that? Because we see, in one hand, there are quite a few work done in the sectors, but many construction work related to regulation. So, how do we do that? So this is show you how do we tackle this problem. So in terms of Singapore. The government actually promotes to use those systems. So at one hand, government would like to use this so-called TRL, technology readiness level, to look at the system's maturity. They want to use this way to mature some of the lower new technologies through public demands, become the first technology adopter. So the agencies that will provide funding to companies responding to their needs, such as our Building Construction Authority, environmental National Environment Agency, and so forth. So for those very early stage technology that require and research development, so their innovation fund will be given to universities and research institute to develop the solution, and subsequently through licensing and spin-off company, then we'll be able to provide a whole solution to solve the problem. So this actually is iterative and a more long-term perspective looking at this. So let's start off to look at the government effort. In our BCA, Building Construction Authority, they rolled out a productivity improvement master plan, which we call the DFMA, Design for Manufacturing and Assembly. So in short, this is a developing our mostly those public housings, private housings, and there are quite a few. They can be done through those modular construction. So this modular construction, not only at the construction level, from the design, factory fabrication, this is what I think Ollie also mentioned. If we can bring all the manufacturing into the factory, they'll be much more productive. And the on-site work mostly will be converted into assembly and installation rather than in situ construction. Yeah, and then along with the information flow to the facility management, so that become a whole construction cycle. So under this, that university industry, they can also provide the trials, because with these paradigms, we will be able to increase the productivity along the way. Yeah. So this show you an idea what are we talking about. In Singapore, because land is scarce. So we show you how Singapore's precast or module factory look like, because we land is scarce. So we have the factory, they're all multi-stories, and then they put automation in some equipment in there, but you do this for many facility precast rebar storage at different floors. Yeah, but this one, you know, is unlike those countries. You have a infinite land, so that you put in horizontal plane, so things will be better. So after all this are done in the factory, those modules will be shipped to the construction site and to be installed along with other precast parts. So this we call the PPVC. It's a prefabricated volumetric construction. Sorry. In short, that's the modules. So these modules weigh about 30-40 tons. After they transport from the factory to the site, they will be stacked on top of each other, just like a Lego block. The crane need to be the high capacity crane for hoisting all this to the designated location. So after blocks are joined together, there are many common areas to be joined through precast component, and there are also some in situ fabrication. But through those kind of modular construction, we can greatly save the manpower. And of course, at the end, we still need to have people going there to do inspection and final finishing. So under this, the big work, with this PPVC, I think Singapore already can save about at least 30% to 40% manpower at installation stage. But of course, we're not stopping there, because we still have a lot of people doing all different here, there, a bit work. So therefore, our National Robotic Program Office launched a 3-year program we call the Robotic for Construction 4.0 from 2019. I was happened to be the program lead. So the goal is to develop a number of linking technology for integrated a solution to enhance automation this process for those precast and PVVC unit from factory to the sites. The vision is grandeur, but we can only start from the very starting from the small, because there are too many things we have to do. We cannot cope everything in one time. Yeah. So this program, we adopt a the whole ecosystems view. So this show you what we have in this program. Under this program, we have 4 major packages. So one is on the so-called smart cyber physical systems. That's actually to develop the AI engine manufacturing of those PVVC unit. Yeah, because even in this plant, they have the so-called MES system. But on top of that, the construction, this kind of a factory, they're very difficult to schedule because of a lot of uncertainties. And we also have robot just to using the vision system to do the imaging, for the supervision. And we have one other robot for on-site work that will be able to bring the heavy load on-site and also overcome obstacles and stairs. And finally, we're working on one project related to crane so as to make it be smarter and the installation quicker. And this is very important because most of the construction site now in Singapore use cranes. Yeah. So for the now let's starting from the first thing. The important thing of this cyber physical system is the integration of PVVC production, domain knowledge, intelligent planning and scheduling, monitoring to achieve a fully connected solution from the factory equipment to on-site equipment with real-time data and real-time decision optimization, as well as manpower development. Yeah. So this whole system will be able to integrate that with the input coming from some of this human. So the system we can allow, it's a cloud-based system. So we will be able to allow the workers to input their schedule and also linking with the machines information. So we also need to, this is in the factory side, but we also need to be realize that in the factory, it will be efficient to build, to manufacture all identical modules in batch production. But if you do on-site installation, it's different because that's horizontal installation. We need to build one floor by floor. So therefore, that's installation of different type of module, level by level. So how to balance the requirement of these two type of works, right? Factory is the same modules, but on-site work, they need to install different modules. So how to balance this become a very important things, which is never been thought of before. We know this kind of modules that manufacturing will be more and more important, not only in Singapore, but also in other places, having like in Hong Kong, they have a large construction project need to be done. Now, let's look at the cranes. Because one of the bottleneck in the on-site assembly of module is the crane lifting and its installation efficiency. So we're developing an intelligent control system for the tower crane to act like just a robot arm that can automatically move around with trajectory control and beam information update with various sensor control modules. They're designed to be fitted into the existing cranes. So show you, this is because the project has been almost completed. So we have done quite a few trials. So this show you some of the few trials we conducted in the training ground of the BCA for evaluation fine-tuning. So from the cabin control to throttle control to hook block and wireless control, all these aspects of works, and this require a lot of new idea and also engineer effort as well. So now, because PVVC unit, just like a Lego block, so it has connector at the four corner linking the module together. So in this project, we also look at the design of the connectors and condition monitoring of the connector in use. For effective connection in the installation process, we have three types of connectors: wire loop, rebar, as shown here, corrugated pipe, and rebar. Yeah. So these are different types. And then we need to, because this different module, they may have a bit different design, different company. So we're trying to look at how do we standardize that, as well as how do we bring that to the so-called monitor that the health all the time. Yeah. Now we mentioned we have a project on robot supervision of the project progress. Currently, this is done by supervisor walking along the sites. So the main technology here would be a 3D vision for the object detection recognition, putting on the mobile robot. And then we also have beam information fusion for filtering the navigation. So wheel robot we use is the most useful platform we use for the operation. But having said that, of course, we can put this onto the drones or leg platforms, but that depends on accuracy. So we would estimate this is about 80% of the jobs. And then we're also looking at see what other possibilities. So let me show you, this is a video of that trials. So what we can do here is to bring this beam information, and then we use beam their maps as a guide to do the navigation, because we know robots do have a so-called SLAM, simultaneous localization and mapping. So with the beam information, we actually can greatly save this effort that doing the navigation, and also we can do some planning before we start. So this shows you how do we look at this as a near completed unit, but we could also do this in a before the staging. And finally, when after they check, they will update this. So this could become a fully automated process. Okay, so now we mentioned we have another on-site robot bring the heavy load for multi type of terrain, including staircase climbing. Why we do staircase climbing? Because right now the work site have very limited workforce. So contractor would like to see we can deploy human workers for more skillful work, such as surface preparation, installation, rather than just finished work. So these can be replaced by robotic means. So therefore, because cope with different type of terrains, we're looking into more as a track vehicle design. So this is how we perform the field trial. You can see that how does the so these machines, we designed it with a multiple payload design. So you can carry goods. This version, it can carry about 200 kg load in one go. We have different versions. The bigger one we can carry up to about half ton. So on top, we can design that with just a bin or with a small forklift that can automatically load and unload the different materials. And we're also considering, we also have putting the manipulator arm on top of that to do some drilling work and so forth. Yeah. So this is versatile, but of course, in the actual use, we are may not do all of that. That really depends on your sites, the type of the sites and condition, and the robot will be able to be done with the robot will be done by the just autonomously or semi-autonomous way, or simply just using the joystick to control. So you can see that this is human operate is one thing, but after we discuss the lot of feedback, I think they like pretty much like if when we do this in the more follow me mode, yeah, because considering the complexity of the sites, if you do autonomous navigation, we may still need to give them some pre-designated route to go. But if you have a human worker, just probably go in the first, and then this robot can follow, that also can do. So this is really how do we look at the navigation capability or the mode that become quite important. Yeah. So yeah, so this show you how it works. Yeah, so this is we can bring back. We also, in addition to the 2 robots, we do supervision or lifting heavy goods. We also identify the manipulator to perform the concrete surface polishing, roughening is important for the PVVC, because after installation, some part of PVVC surface still need to be polished out, need to fill the gap with grouting, and this is important. But now these are all done manually by equipment, and all this is strenuous and also unhealthy to the workers. So this work is now has been tested in SIT, Singapore Institute of Technology, and then where also there are several contractors who are now doing the field tests. So this system now, we're adopting a cable-driven system with the frame support. So normal for required by the one grinding or roughening considerably and also can be achieved through this configuration with carefully designed layout. But the normal force is not as large as those for the metal grinding. So this system, why we adopt this kind of design, because it will allow us to do fast in this installation and with the covered surface area of arbitrary size. Yeah, so this is some preliminary result of this grinding, which is much smoother than the manual work. The researcher had some prior experience dealing with aircraft grinding, so the changing this to a cement surface is also is quite straightforward. Now, as I mentioned, this is a government lead project, and then we have universities and research institute as the perform the R&D work, and we are testing along with the several industry partners, from the contractors to the end users, and even with some equipment owners. But for others, there are some we call the government lead demand project at the more mature stage. Then the government will be able to help us to move in to help to test, and then to speed up that commercializing effort, because we know construction site normally in Singapore, they are limited, and the quantity is also yes. So these are some work done by our Transformer Robotics, which is the one of the construction or built environment robotic company in Singapore. So Transformer Robotics was spun off from NTU since 2017. Yeah. So we had under those projects we done by JTC and some BCA. So over the past few years, we're working on robotic painting and coating for buildings and other infrastructure as well. So we reckon that construction scenario not standards. Hence, we develop a number of platforms to adopt different construction environment, from residential, commercial to industry estate. And we also use the same automatic control to extend the robot functionality just beyond the spray painting to other tasks. So here we show you one of our commercial painting robots that can paint up to 3-meter range. This is for car park painting. So new or renovation work without much human intervention. So in this way, we can save the manpower. Of course, we cannot say we can completely remove the manpower, but human just need to go in beginning to do some preparation work. You mask out this area, and then after that you come out, and then the robot, the human need to do some wrap up work. So I should say, humans still need to do probably about 10 to 20% of the work. The majority of the process will be done by robot automatically. So the robot also the scan, because we use the scan, so the robot will be able to recognize you have window or door to avoid that. Of course, the application scenario, including the on-site work, off-site work. So we have done in different locations. And also, protective coating is another area that we're working on, because these areas that require very precise coating, and they are very hazardous and unhealthy environment. So this is the area that most people that you want to replace by equipment or by robot. Yeah. Now we also further refine some of our robot, because in the early stage we built the robot we call QuickBot. This is for the building quality inspection, for the handover process between contractor and developer, and also the house buyers. Yeah. So automatic inspection tagging with AI imaging process can be done here. The main proposition is that we can do document and the data automation, as well as giving them a very objective inspection result. So if you see on the right, we also develop robot just for the floor and tile hollowness check. So the robot will be able to scan, giving a map of the room, and it will cover all of the ground and generate a hollowness report, and for the contractor to decide whether you want to repair or not. So these tools would be able to help these different parties a lot. If you even just look at hollowness, right now we're using a rod to do the work, and now you're using robot. So this improvement is becoming tremendous. Yeah. So here are some videos showing the robots. Yeah. So on the left, that's the QuickBot. So it uses all this the 3D scan as well imaging technology, because we do have dimensional defects. We also have surface defects, and we can collect the raw data. And with the raw data, we'll be able to convert. We need to do assessment, yeah, because all this having some quality standard. We build this according to the BCA's Conquest standard. Yeah. And you can see on the right, this gives you the knockbot. So this one we tested in a number of residential projects for now. This is still a prototype. We plan to shrink down this robot. So it used the acoustic signal to do that, and then give you the full coverage to look at the whole place. So it's quite a small, interesting project, because this is essentially a mobile robot, but with a payload. Yeah. So far we have quite a few number of projects done those in residential, commercial building, and also industry. So we're in discussion with some further use of this. Okay, so I think I would like to use this picture to summarize. Yeah. So as I showed you before, construction ecosystem is very complex and large. AI robotics can be used in any aspect of this ecosystem. However, to facilitate adoption, right, the government push and traction play a critical role for this deep tech company to continuously improve of the products, because they're new breed, right? So we need to go through all this kind of iteration and iteration. It is not something you can get it next day. Yeah. And the COVID-19 situation already speed up that adoption, especially, we don't need to take a lot of our effort to educate the client. Now they really know this robots is something is quite useful. Yeah. So therefore, we will be able to see this kind of adoption and collaboration, among the researchers, government, and industries will be more fruitful, because a lot of things are new. There's no way that you can single-handed to do that. Okay, so with this, I'll just end my talk here. I would like to acknowledge all the people from faculty members, research staff, students, as well as our funding agencies and collaborating partner here. Okay, so thank you very much.
Thank you very much, Professor Chen Yiming. You have just heard from co-founder and chairman of Transforma Robotics, Professor Chen Yiming. And I would just now like to remind everyone